I was like, I don't know what this bat thing is, but I'm probably gonna go to Open Lab today.
All that time ago.
Yeah, I'll come for an hour.
He's packing up.
I was like, oh, that sucks.
Yeah.
So, what am I supposed to do?
I'm sorry, but like, all right. So what'd you get for this one? See if I can make that smaller. Here, we'll stick with blue. Okay, so what did you do? I'll give you a hint.
Carbon bound to carbon.
Okay,
Then bound to the oxygen.
okay.
One hydrogen on the oxygen. Rest on the carbons. Two on the middle. Three on the end. Two lone pairs on oxygen.
Okay. Did anybody come up with a different one?
Could you put the O in the middle?
Yes, you can put the O in the middle. So you would go C, O, C, and then each carbon gets
Oh,
3 hydrogens. Do you see that this fits the formula just like that other one does? And both of these things exist. It's freaking me out how it's like delaying. Okay, and both of those exist. This is commonly referred to as ethyl alcohol. It's the alcohol that you can drink. If you're over 21 and you do so in moderation, don't drink and drive. You heard it here first. Okay, so that's why most of you came up with that one. I'm positive because it's ethanol. Okay, so it's the alcohol. This one, don't drink this one. You won't be drinking or driving if you drink that one. Okay, so if I asked you to draw a structure for C2H6O, either one would have been correct. Okay, and I want to make sure that you see that they're different. Okay, so we have, this is the ethyl alcohol. You have CCO. Okay, and then the whites are the hydrogens. Now on my model kit, the black is carbon, the white is hydrogen. The red is oxygen, but you'll notice what is not shown here? The lone pairs, okay? They're really in a good way to do that on model kit. Okay, now here's the other one. So you see how it goes COC. The connectivity is different. Connectivity means how the order that they are connected. Okay, hang on. Okay. When I moved stuff from Keynote to PowerPoint, it kind of added some craziness that wasn't there originally. Okay, the order in which the atoms of a molecule are connected is called its constitution or its connectivity. Constitution means like makeup, how it's made up. It's not just the Constitution of the United States, okay? There's Constitution that has other meanings, okay? So these two have different constitutions or different connectivities. So they are referred to as constitutional isomers. Okay, so up here, you're going to tell me which structure below is the correct one for the formula C3H8. Okay, I opened it, so it should be okay. I think 23 is our number. Yeah, 23. All right, so I had 22, so I guess I got one more. Make sure you got the dot thing. Can I not count?
It's 23.
Yeah, okay. Okay. Are we all here? Okay. Yes, it's D. Okay. So why isn't it just C? Well, do you see that A, B, and C are all the same thing? Okay, you have a carbon attached to a carbon attached to a carbon in a row, a carbon attached to a carbon attached to a carbon in a row, a carbon attached to a carbon attached to a carbon in a row. So you see, you can hold a molecule, write a molecule, draw a molecule numerous ways, and it isn't necessarily different. Okay, so we like to write it this way. This is our favorite way, but you see when we make the models, they're not always lined up like that. They kind of have little jaggies in them, okay? This is pretty close to what it really looks like. That's why I like this kit, because it does that. Okay, is that making sense? All right, let's go to the next one. Okay, so here we go, constitutional isomers. I guess I need to move that other thing after this. Have the same molecular formula but differ in connectivity. This is important that they have the same molecular formula. Don't be adding in extra carbons. Okay, you got to stick with the formula that you're given. They are also referred to as structural isomers. Okay, and we're going to draw all of the constitutional isomers for the formula C3H9N. Okay, so we're putting a nitrogen in there for you. All right, I put it on another slide so I'd have more room. I decided that was going to be too hard for me to draw. Okay, so I have 3 carbons, 9 hydrogens, and a nitrogen. How many valence electrons should I have in each picture? Okay, how many do I get from the carbons? The hydrogens and 1 nitrogen. Okay, so I should have 26 valence electrons. Do y'all agree? Okay, why don't I have...
Did you not give us a spot on the slides for this?
No, I added it later.
It's on there, though.
It's on there, but I decided I wouldn't have enough room. So I didn't, so sorry. Okay. Okay, so what do you want me to do? Here we go. 3 what? Okay, I got 3 C's.
Add your nitrogen to any of them.
Well, I want you to be specific and pick me.
There's like 8 ways.
Okay, so how many hydrogens go on the first carbon?
3.
Second one? This one? Okay, how do you know these two don't get 3 hydrogens?
They already have 2 bonds.
Right, you can only have 4 bonds to nitrogen. To carbon. Golly. All right, nitrogen, I'm already worried about it. Nitrogen gets how many hydrogens? 2. Remember that nitrogen makes how many bonds? 3, and it has you're drawing Lewis structures, put the lone pair in. It's freaking me out how it's doing that. It didn't used to do that, so I don't know. All right, that's 1. There's a few more. All right, give me another one. Okay, if we go N, C, C, C. Do you see that is this one turned around? Ah, okay, so how can we change it up so that it doesn't do that? What do you think?
Add your nitrogen to one of the middle carbons.
Okay, so what do you want me to write?
C, like just do a line of C's.
Do the 3 C's? Okay.
Then the middle one, put the nitrogen.
Okay. Do you see that this one is different from this one? Okay. And y'all, every one of these things we're going to draw exists. Okay. This is why there's billions of organic molecules. All right. So how many hydrogens does this guy get? 3. How many hydrogens does this carbon get? Ah, everybody see that? And this guy gets 3, and the nitrogen gets 2. Okay, and I want you to notice that I still have the same formula. Okay, there still is 9 hydrogens. Still are, I guess I should have said. It's freaking me out. Okay, now what's missing?
Lone pair.
Okay. Don't forget your lone pair. It's really important because you're going to have to use those lone pairs later on. Okay, so we got 2. There's another one.
CNCC.
Okay, so you want me to go C, N, C, C. Okay, how many hydrogens does that carbon get?
3.
How about the nitrogen?
1.
Okay, it gets 3 bonds and it's already got 2, so it's only going to have room for 1 hydrogen. Okay, that's 4 of my hydrogens. Where are the last 5?
2 on the left, 1 is the nitrogen.
Okay, and this guy gets 3. So your organic molecules follow the rules and don't, don't come up with a billion exceptions. So they're a lot more fun to draw. All right, guess what? There's one more. Just one more.
Put the N out of order.
Okay, so what do you want me to do? Put the N where?
In the other middle spot.
All right. Okay, and then what do you want me to do?
Put 2 carbons on the left and 1 on the right.
Okay, if I do this, do you see that's this one flipped? Ah,
Carbons on the nitrogen.
dang. All right, what else could we do?
All the carbons on the nitrogen.
Yes. Is that going to erase that? Oh, I could have leave that. Okay. I successfully erased only one thing, sort of. Okay, so the 3rd carbon is going to be attached to the nitrogen. Okay, and each carbon is going to get how many hydrogens? 3. How many hydrogens does the nitrogen get? There's no reason that you have to have a hydrogen. You just have to have your bonds. All right, did I get all my H's? Man, that is really weird how it's lagging. Okay, those are the 3, or 4, I should say. Okay, they are constitutional isomers. You can also call them structural isomers. Okay, my Mac was plugged in for the last 3 hours, and now it says it doesn't have power. All right, I'll be right back. Wait, I'll give you something to do, because I'm good that way.